actually pretty easy. What you should be doing is that um, so what we have here is that we're trying to find the Mach number. Before we find that, let's just recall some of the previous rules. So if the Mach number is less than 1, therefore it's subsonic. And if the Mach number is equal to 1, it'll be sonic. And if the Mach number is greater than 1, it's going to be supersonic. And if the Mach number is way more than 1 and way more than 5, it's going to become hypersonic. Right? So let's just find that out. So I know that the Mach number is equal to the velocity or the speed of sound. So this is going to be 260. This is going to be 330. Finding that out will give us 0.788. All right. So let's just see. Is this less than 1 or is this greater than 1? Let's just compare the numbers. Therefore, it's going to become how much? It's going to be subsonic. Subsonic. All right. For 62, there's two methods to solve it. What you could do is that, first, I'll just show you guys how to do it. We come to a problem, which is that 62, right? So the velocity of the aircraft is in kilometers per hour, whereas the speed of sound is in meters per second. Okay, so what should we do? Let's just recall another rule. So from meters per second, this is kilometers per hour. If you want to convert that, what you should be doing is multiply by 3.6. And if you want to do the opposite, so kilometers per hour to meters per second, what you could do is that divide that by 3.6. All right. So let's just find that out. So the Mach number is equal to the velocity over c. This is going to be 120, 125, 1250. C is going to become, I'll show you guys how I found it. So C is equal to 315 meters per second multiplied by 3.6, which is going to give us how much? 1134 kilometers, kilometers per hour. 1134, which is going to give us the answer of 1.1. All right. I'm just going to call this the first method. So method method number 1. So this gave us 1.1. So let's just say you want to do the other. So the Mach number could be m is equal to how much? Vc is equal to v. So c could be like 315. We could do the other method. So the other method could be, give me a second. So the other method could be, we could just say that v is equal to the number itself, which is how much? 1250 kilometers per hour. Divide that by how much? 3.6, which is going to give you the number of 347.22. Factoring that in, it's going to become 1.1. All right. So what about 163? So for this question, we're trying to, yeah, the mass and heat and work are not allowed to cross the boundaries of the system. So if there's, so the mass, right? We don't need mass. We can't have heat. And we can't have work. Therefore, it's going to become what? It's going to become isolated. Isolated. All right, for 164, it's basically weight is equal to mass multiplied by gravity. Mass here is it's 10. Multiply that by the gravity, 9.81, giving us 98.1 newtons. Okay. So for 165, very simple. We know that 1 pound, 1 pound mass is equal to 1 pound force. This only applies for the, yeah, it applies to both. All right, 166. So here I know that 1 kilojoule is equal to how much? 1,000 joules, which is going to become valid. I know that 0.001 megajoules, which just do, since it has the since it has m, that's automatically going to become times 10 to the power of 6. So let's just do that really quick. 0.001 times 10 to the power of 6 is going to give us the value of 1,000 joules. So that's valid. It's going to become valid. Okay. What about the other one? So I know that work is equal to F multiplied by the distance. So let's just say we have 1 Newton here. The work is also going to become here. I know also the work is going to become as 1 Newton meter. So therefore that is valid. So 1 Newton meter is going to become valid. Okay, so what about the other one? I know that 1 kilojoule equals to 1,000 kilogram meter square over the second square. So therefore, so therefore the 1 kg, 1 kg meter square per second square. This is going to be the wrong one. So this is our final answer. All right. So 167. Let's just find that out. 167. Right. What I know here is that this is for energy. This is energy rate. Energy. So what's our goal here? So what's energy? Energy is just power multiplied by time. This is power over time. So this is just a rate, energy rate. So this is not valid. What about C? Okay, so the answer here is going to become B, since B is just a some sort of power with respect multiplied by time. So the answer here is going to become B. All right. What about C? This is the same problem. It's an energy rate. What about D? D is just a power. What about E? E is just a power. All right, for the last question, 168. It's very simple. So for 168, what we should be doing is that we're trying to find time. It's pretty simple. Energy is equal to power multiplied by time. Just be careful with the units. So this would become 26, 0, 0, 0, 0, 0, 0. And our power, since the base units is, what was the units? Yeah, so the base units is supposed to be 7 kilowatts. So we just have to turn back to kilowatts. So the answer is going to become 7 times 10 to the power of 3 expected time multiplied by time. Time is going to give us in hours, which is going to become 3714.3 hours. And like that, you're done.